I'm system engineers inside former Meru, now Fortinet. Been that since 2011. Prior to that, working with distribution of the old Meru products in Denmark locally. So I have a long history with the technology. And the agenda for today is Wi-Fi in the future. First, the near future. Then we will have a little slot about a long way from now, far away, so to say. 5 years is a long time, so that's how long I would try to look into it. So, since we got acquired by Fortinet, security is a key issue, of course, and not only in Wi-Fi, but in your infrastructure in general. We all know that we kind of encrypt the traffic between the clients and the wireless network. But that's one way of looking into security. Another way of looking into security is identifying clients who will use my network or your network. We use probably at your own, so everybody is identified, so we know who the people are, who the clients are. We don't necessarily know what they are doing. If we want to know that, we're going to dig a little bit deeper into what's going on in your Wi-Fi infrastructure. That's also a part of the security. Hasn't necessarily been so important back years, but it's starting to get very, very important, and we want to know what's going on. The Wi-Fi infrastructure is kind of your edge in the network. That's going to be the first hardware component that your wireless clients will connect to. So that's why we need some kind of a security. So all of the things that we have around this is based on a security approach. That's very important. Somebody may not use it so much because it's not necessary, but a lot of people, a lot of infrastructure installs will gonna need the security approach. We're gonna use it across a lot of different platforms, mobile device, and so on. So with the product portfolio that we see today from Fortinet is now that we of course have a cloud offering. Yes, check. We have integrated where you will see that your FortiGate, your firewall, will do some kind of wireless controller stuff. And the topic for today is the infrastructure. That's where we, Meru Technology, fits. That's where you have dedicated wireless controller units, hardware, virtualized, but dedicated resources for controlling your Wi-Fi environment. So what we did at the Viking ship was that we had limited time doing the radio design. It was kind of fixed. So we deployed a couple of radios in the area, 168 exactly, and did some planning, general planning, radio planning. And then we sat Wednesday morning at 9, saw the participants joining because it was no touch environment. And we were kind of a little bit worried. Of course, you should be. But as Peter mentioned, it worked flawlessly day one throughout all the 5 days that they were inside the Viking ship. So it was the first time for us to be there at that kind of environment, but we took the challenge and we will be there again. So we have a lot of experience for that now and may have some design changes, but that's a totally other topic, not for today. So how do we fit in with the products? As I mentioned, It's an infrastructure product, so we will have a dedicated wireless controller. A lot of wireless systems have a dedicated wireless controller. Our approach is a little bit different when we talk about the radio, which we will start shortly. Since it's a little bit technical, so we have to do this first. The key feature things that I would mention today is that we make the network or the infrastructure making the control of the environment. We take care of the roaming. We do airtime fairness, not packet-based. That's another way of doing fairness. We do single channel, one single channel, two single channels, multiple single channels, depending on your needs and the environment that we will be in. So first of all, how many of you have been involved in designing and, of course, running your infrastructure, but designing your wireless network today? Just running it or designing it is a little bit, could be a little bit of a challenge. What we do is that we kind of take the actual access point and make a virtual access point. So we are kind of leveraging from the cellular network and what VMware have been doing good. So if you take the approach that you have a lot of hardware, you have a lot of access points, they are all individuals access points. But on top of that, we make and create a virtual access point. So from a client perspective, smartphone, tablets, whatever, you will not see here all of the individual access points. They're kind of taken out of business because we present it as one virtual access point. That gives us a huge advantage, since that normally it would be a client decision which of the access points to connect. So if I would be a client around this place, I would, of course, hopefully, not every client is equally good at that. Hopefully, I would choose the best and the closest access point. Traditionally, that's the way we do. When we create the virtual access point on top, we take that decision away from the client. Remember, client only see one AP. So the decision on which actual physical AP the client will communicate with, that's our decision. That's decided inside our wireless controller. So each physical access point, you know, it has a unique address, not the network name like Radisson Guest or something, not the SSID, that's not the unique name. Each physical access point has a unique address. Just when you go into a switch and plug in, you connect to a MAC address. That's the same here. So we create a new virtual MAC address, which we send in the air from all our APs. So that's the way how we kind of remove the decision from the client. So if you have clients that are very, very good in making those kind of decisions, it's okay. But imagine if you have 500 clients which may have a bad networking driver or something, maybe outdated. They're making bad choices. We kind of remove that because it's our decision. We want to be in control of what's going on. Okay? Yeah? Questions? let them come. Next, the advantage when we do this is moving clients. So if we are in a typical, in your environment, probably a classroom, auditorium, clients are pretty much stable, not moving that much, hopefully. Anyway, they see a lot of access points and jump between them. We kind of take that movement or that unnecessary handoffs away, since we have the control. So imagine an auditorium size is 100 seats or something. I'm just guessing a little bit. We may have 5, 6, 10 APs near the auditorium that the clients will jump between. What actually happens when a client jumps between 2 access points or 10 access points is that it's going to be ineffective, because the time the client is spending on switching from one AP to another AP, that amount of time the client cannot send or receive any data. That's bad. So imagine that you have 1,000, 2,000, like the Viking ship, that's going to jump between a lot of APs. That's going to get like a nightmare. And that's why we actually designed the single channel and the virtual AP infrastructure, because we want to reduce the unnecessary handoffs so we are efficient. That's the roaming part also, since we may have moving devices. I can walk here, that's okay. Voice, hospitals, a lot of moving clients, as Alan mentioned, Norwesgruppen with the truck and logistics. Fast moving clients. When the client is doing the handoff from that to that to that to that, it may jump between 2 or 3 and misses something that's ineffective. So for roaming to work, that's spot on. Because we know and we can detect if the client may be a phone like SIP client, like Microsoft Lync or Skype for Business today. When we detect that type of client, we know that every 20 milliseconds, that client needs time in there. It needs to send the next packet. And therefore, we can make sure that that client will get higher priority. It could be, if we go into the education market, we could say that the teachers, the staff, gets higher priority. We could say that a specific application gets higher priority, leaving the rest to students, sorry to say for them, but we could choose that. We could choose the other way around, of course, since they have to do a lot of work too also. So the controlled handoff between our access points is a key issue, and I will say that many, many times, that we need to be efficient. We cannot remove the fact that all wireless infrastructure, whatever, it's just like an old hub. It's a shared media. So if we put in 1,000 devices, they need to share the airtime that's available. And we need to make sure, in order to scale, that we can do it efficient as possible. That's our main goal here, is to do the radio communication as efficient as it is possible to do. That's the main goal. So that's a key factor for us. Next thing, so now we have kind of control of how they will connect, how they will communicate. Next thing that we bring into the infrastructure wireless is an airtime fairness approach. So imagine that if you were a slow client and you're going to be the fast client today. Traditionally, we have an approach that says that we can each send equal amount of data packets. So you get allowed to send 10 data packets, and you get allowed to send 10. Since you're the slow client, you will use some amount of time, and you will be very fast and use less amount of time. So that's a packet-based approach that everybody get a fair share of how many packets we can send and receive in the air. Taking that away and swapping it into airtime, since time is our resource here. So now we're going to say that you get a fair slot of the available airtime equal. So you are still the slow client, sorry. You're sending 1 data packet instead of 10. Now you can send 200. Is there a fair approach? In our opinion, it's a fair approach, saying that you're fast, yes, you can do this and this and this. So we allow you to have the opportunity to send a lot of data packets. Especially good when clients are moving away, because the further away you go from the access points, you're going to get slow. In order to get very, very fast connections, you need to be very close to the access points. So one reason you could have a slow device is that you could be at the edge of the coverage. Nothing to do with your client, you're just at the edge of the coverage. We don't care, because you get a fair amount of airtime. And if we scale, not by 2 clients, that's pretty easy. Take the Viking ship, take the auditorium, the halls, 1,000 devices. We don't increase the airtime. The airtime is kind of fixed, it's a shared thing. But we can make sure that it's equal to all of your device. That's the airtime approach. Instead of calculating how many packets you can send and you can go so and so in your speed. So having the airtime, making it more fair to all of our devices and all of our clients. That's the approach. It's going to be efficient. It's going to be effective, because we don't want to waste time on doing retransmissions and lost packets and all that stuff. Because that's when we see the clients are going far, far away and they need to retransmit and so on, but they just get the same time of airtime as the rest. Especially when we have time sensitive, could be Citrix, terminal server applications, all like that, Skype, Link, voice, whatever. That's where we really use the airtime approach. So we know when your client needs a new time slot. We also know that a client can kind of be destructive. Let's say we have a bad client that's going to eating up the air. Still, we are putting in a box and getting the airtime and making sure that rest of the client gets their airtime. In order for this to work, we pretty much rely on that the clients are following the Wi-Fi standards. There's a back-off period when clients are not hearing anything in the air. The client, per standard, have a random back-off timer that says you're going to wait 4 time slots. You're going to wait 6 time slots. So next time you will try to get access as a device. Since your back-off timer is different, you will get access and you will get access slightly later. We need to divide that into time slots. That's what we do with the airtime approach, making sure that a lot of different devices get their fair amount of the network. That's two things, what we do. Next is kind of the key fundamental stuff that we need to have in order to make the other things work. Traditionally, we see that we use different channels or frequencies for our access points or for our radios. Check, we can do that if that's needed for our purpose. Secondly, or next, I would say, traditionally we have been building all our Wi-Fi products in one channel. One channel in 2002, 4, 5, 6, up to recently has been quite sufficient. And that's because that instead of having clients doing stupid things, we are so efficient that even that we share the same channel, because that have some things that we have to take care of, because of that we are so efficient, it's okay to share a channel. So we know here that the AP or the radio will communicate in different time. We can't have access points communicating at the same time. That's a bad thing, because that would make collisions. We kind of avoid that. So not only do we share the airtime for the clients, we also take control of when a certain amount of APs is talking at the same time. So if you have collisions when access points hit each other, we don't see them very much since we have the single channel, and we take care which access points will actually communicate at a given point of time. That's efficient because we don't see these collisions. So we're able to handle more traffic. We are able to handle more clients because they don't need to roam. They don't need to see all the collisions made by the access points by themselves. That's going to be removed. We may have clients that have collisions between because they communicate at the same time. Nobody can control that. That's a client thing. But all of the rest that we are able to control, that's what we will do or do. As I said, starting up to recently, one single channel were kind of enough. We also saw a demand or a request for having the capability of separating into multiple single channels. So we saw the gathering video where we made 8 single channels in the Viking ship. And why did we do that? We needed to add capacity. That's one thing. But we also had the option, and we did, for reserving one single channel to a video source. So not only adding capacity, but putting in one dedicated channel for dedicated service. We see it in hospitals. The telemetry equipment, we actually do heart monitoring wireless. So be careful. But it is pretty awesome that we, by doing one single channel dedicated for that equipment, they now say it's safe to do telemetry heartbeat pumps, and all that wireless. That gives the hospital the opportunity to move the equipment around. They can even put a location tag so they know where it is. But they have the mobility. They don't have to plug it into the wall and something like that. It's safe to play wireless because we dedicate one single channel, could be that one, for that purpose. So that's how we do multiple single channels today. A lot of installs is still like that. That's fine. That's awesome, that's good. Everything is happy. And one last thing, we don't reduce the output power. So normally, in order to avoid collisions when we do multi-channel, that's us and everybody else, we're kind of controlling the radio and the output power. So we're putting all in full output power, using fewer access points. The one we're not using, we can put that in to a new channel, adding capacity. So in totally, you will end up with the same 2,000 APs in total, but you have to design the flexibility to do this. We could take this hotel as an example. In the conference area, we will see a lot of people, a lot of devices. So that's where I would add maybe 1 or 2 more single channels. Throughout the rooms and the rest of the hotel, 1 single channel. So that's the approach that we will have. Timing.
Just one question.
Sorry, you will have to get hold of this one.
Okay.
Now it's green, thank you.
Okay, just one question. When you're using the term channel, you actually mean specific frequency?
Yes.
Okay.
Correct.
Okay.
So.
And well, of course, I have a microphone. Another question. Is it you have a smart design here, good approach. But how difficult is it to control the client? Because the client, the software, was not designed to. It will also try to control the network. If you see a strong signal somewhere else, it will try to connect to that network.
There will be certain clients that are having their own software. You have, for instance, SpectraLink phones, especially designed with their own software for making good choices. If that's the case, you can do like this. And you can combine it into having another area doing like this, where you don't have that kind of device. So that's correct. Specific device making good choices, then it's fine. No trouble. We can do this. We can do this. We can do this. That's the flexibility. And that's the design. If we have bad clients, that's bad. But that's bad everywhere. If you do this, this, or this, it's still going to be bad. That answers your questions? Yeah. So we cannot control the clients, correct? We don't do that. But we can control as much as possible. And since we have the airtime approach, we can kind of say, okay, yeah, you get a share, but we don't forget the rest. They will get their share as well. So the combination is between the virtual AP, the fairness, and the channel frequency. That's when you get it all combined into something good. That's the key elements. That's what we do. And that's how we're going to do it. that's an example of what we actually can do. And that was how many years ago we did that test? Anyone would like a guess? Last year? 10 years back? What's the best guess? 5? Anyone closer? I think you have seen it before, maybe. That's correct. So we did that at the early stage of 11N standard when it was introduced. And we said, how crazy can we go? We were using iPad, iPhone, Apple devices. We just talked about Apple. And the main thing here is that how many Apple devices do you have on your network today? I mean, is it half, 25%, 100%? What's the approach? Half? 60, 70% is Apple devices today, and we have to deal with that. And I'm not going to shoot Apple today, but they may have not the best device in town today, at least for handling Wi-Fi, and that's why we choose that kind of products when we do that kind of tests. So it's very important for us to have a joint venture with Apple, BlackBerry, Ascom, Voice, all vendors. We need to have interoperability test in our test lab and making sure that the engineering teams is working together for making the best choice. So one of the goals is that when we kind of take all the client decisions away, if the client is an iPad, that's one thing, but the iPad don't have a choice. It's my decision or my controller decision how it will connect. So day one, we just designed for taking care of devices that's doing not the most efficient things today. So as Alan mentioned earlier, education market is a vertical that we kind of from the early beginning had a lot of focus on. So a little bit how we fit and where we fit into this market, and a little bit of why we fit. The why we fit is of course because of the technology approach that we have. So if I may ask some small questions, don't be afraid. How many clients do you have on your network today? Approximately?
166 now.
166, what's the maximum?
Usually about tweaks out to about 230.
230? We take all the around?
Well, I don't know actually now.
No, but in approximately maximum of
100, maximum 200.
Maximum 200. Yes, we're going down here. Okay.
Maybe around 300?
300 approximately.
Yeah, I'm guessing one of the campuses approximately 500 maximum.
500 maximums.
500.
500 as well. So that's some of the audience today, is that between 100, 200, 500 devices connected. So what we do with our technology, what we give you the opportunity to do is that if you take your 500 clients, they probably 80-90% of them logs in that time, which is seconds, minutes. 8 o'clock in the morning, everybody in the classroom, everybody starts their Mac, or nearly everybody. 10% may have a Lenovo, something else. They need to get online and ready in short time. That's what we saw with the video before, is that if we take down the network, 500 devices connects at the same time. And that's in the same room. If you scroll back a little bit, it were client per client per client per client per client, very, very close. That's insane to do a test like that. But that's what we do. The technology behind this is the reason for the success. We're actually able of doing that. Long-term customer for us is, I'm going to kill that, University of Houston. They recently did approach for doing 11AC upgrades. So they went to us, since they were a long-term customer, which makes us happy, that they would like to see what can we do with the 11AC standard. How many more APs do we need, if any? And how do we do the transition and the migration from 4,500 APs into the new one? It's not a one-day job. I would say it takes a little bit more than that. So we had a couple of meetings and we went on for a plan and doing the migration from the 11N BG, older stuff, and running 11AC in the campus. And they took a campus, they went online with the beta products, the first beta products that we had, and got it up and running at the campus, saying, okay, Meru Engineering said it's going to work. Okay. So engineers went to University of Houston, stayed there, monitored, good, got a lot of feedback, changed small things, and running. That's the education. We need to do this. We kind of live and die for that, so to say. And that's why University of Houston have been a customer for us for a very, very long time. A lot of students, a lot of access points. I mean, large may say something, but it's spread across huge campus. That's what we do. Another one, even more access points. So why do I take the approach of having large installs? What's the purpose of showing you large installs? Main purpose is that when we say single channel, virtual cell, you know, the virtual AP, which is kind of different from what everybody else is doing. Very often we get the questions, are you really sure that it is working? And if I can place some access points, a lot of access points, if I can use our technology, and if I have long-term huge customers, yes, it is working. And that's the reason for showing what we can do. So we can scale from 2 APs to a lot of access points. And that's the main goal for showing this one. And also, of course, that we have limited IT staff. That's probably same for everybody here in the room. We don't have huge staff. We don't have huge amount of time to do the management. It needs to be easy. So take the single channel approach, having your 200, 500 clients connected. If you find out that some of the clients may have bad coverage, yeah, we need a new AP, right? So we need to do the traditional radio planning. It's going to be that channel or something like that. But if you were on our wireless, you just need to deploy a new AP. You may have a default template, so it's going to be automatically configured like the rest. Whoopsie, all in one. You have extended your network. No planning, It's just like when you need some light, sort of. You're gonna turn on a new bulb because you don't have the light. That's how we make it easy. If you have a venue like the gathering that we saw before, you may need to do some radio planning and designing, yes. But a lot of installs, since it's spread across, it's easy because we take the control and makes it easy. Going into Norway, as Alan mentioned, it's new for us to be on the agreement with UNINETT. So university, we don't have that much. You saw one in Houston just before that. And Bergen municipality has been a Meru customer since 2007, I think, correct? Yeah. So again, it's a long-term customer. It has to work. We need the ability to grow. I will show you a slide a little bit later how we grow, especially good. They don't start it at 2,300 access points day one. They started to swap different vendors. They have bought from different schools, different kind of equipment. They need to make it into a centralized wireless management because they saw that they need to scale. They need to be able to handle all of the devices. At the beginning, it were municipality-controlled devices, of course. So today, we see that that's going to change, or has changed. So I assume that none of you have your own device. I mean, the students, they have their own device, and they will use their own private device on your network. So you need to onboard them. You need to get them inside the network. When we started install like this, it was very easy. We had, let's say, 1,000 exact equal laptops. That's, I mean, it's not easy, but it's easier than to have 1,000 different devices, Samsung tablets, iPads, Dell, whatever, Surface. So that's the approach today, that we need to be able to onboard them, not only to get them wirelessly connected, but also that we need to onboard them into the Wi-Fi network. And that's the approach that we see today that they're going to do. Especially if you see that history, which I kind of like, is that it's even earlier. 2006, and now we are nearly 2016, still running, strong. They have swapped a lot of equipment throughout the years, starting with old technology standards back then, starting with a controller on each school. That was the kind of the install back then. Today running central infrastructure, virtualized, today on VMware. And they are now starting to onboard all of the students by using the Meru Connect solution for onboarding. So that's going to be the front end for every login at the moment. In the back end, you could log in using social media, your Eduroam account, which is key factor here, or a local account, Microsoft Active Directory account, LDAP account, Google account, Twitter account, whatever. That's in the back end. But you need a nice front end, easy to get you onboarded. And that's the project that we just started. That has actually nothing, or I would say nothing is not the right word, but it's expanding not only to the wireless. We can take the wired environment as well. So if you ever plug in your switch for some reason, you could be onboarded by the Connect solution anyway. Mostly, of course, wireless. They did the first 11AC install when the standard came out, and are still using today this AP model. That's an AP model, hardware-wise, from 2004. So it's a 12-year-old, nearly 12-year-old access point that are running today, which I kind of find quite okay. I mean, it has the performance that the standard has, but the hardware is running. Single channel, virtual cell, running today at the same time. They need some capacity, so they will swap the AP, maybe add some access points, maybe add some layers, since they are now controlling the nursing homes. They have a new system for doing voice, so we are making a new single channel layer for that purpose. So they have really taken advantage of the way that we do things. It's not a university, but it's kind of similar. If we can do this, I would pretty much say we could do pretty much everything. So back to the scaling thing, we see that University of Toronto is another great story. Not so long back, as we saw here in Norway, but still starting with quite some access points, just 1,000. But what I think is kind of interesting is the scale from what we have seen in 5 years. The throughput capacity per device is 10 times in 5 years. That's pretty much. How do you deal with that? How do you increase your capacity? What do we do, actually? I mean, you see that the capacity is growing. So anyone would like to say, how would I deal with that? Anyone dare to answer? I don't have it, but maybe you have it. Anybody would volunteer? How do we deal with the increase of the capacity 10 times in 5 years? If you would see that, Alan, what would you do?
Design.
Design? You're my man. So you would go for design, and one of the things that you would probably need to do is to add access points, right? So is it easy to add access points? I mean, if you go from 1,000 to 3,200 in 2 years, that's a lot of access points you have to add. But you have to add it because this one is driving the, right? They're doing video streaming, e-learning, probably. A lot of video streaming. They do that. So that's what they do. But it's easy. I mean, if it's too dark, if I don't have enough light, I just add more bulbs. Simple. And do some design with that. Some areas with more channels, some areas still remain one single channel because that's pretty amazing enough. But I need to do a new design, I need to add access points. I have to do that. I have to scale. So we just add access points and have the system controlling the environment. I don't care if you're using an Apple, iPhone, iPad, MacBook. Oh, I do care because they may not be the best in Wi-Fi, but so of course I do care, but I have to manage that as well as if I had 1,000 equal exact same kind of device. I have to onboard it, I have to scale it. And that's what we do here. So that's just an example of when you need to scale. Because now we are here. So 2020 is near, it's close. So what would be the number in 2020? Are we going to increase 10 times again? Probably. More? Maybe. How much consumes a HD video stream? Anyone knows how much do we consume when we have a 1 HD video stream? You're gonna, no? 5, 6, 8 megabits per device. Try to multiple 1,000 video streams. You saw The Gathering, they were streaming Justin Bieber. She was happy. I was amazed that it was even possible to do that. At the same time, there was a concert in the arena, but she was watching Justin Bieber. That's good. But we will see that when you go to a stadium, watch football today. Yeah, you watch the game, of course. But what do you do at the same time? You're streaming another game on your device. That's what we're going to see. We have a customer. Actually, this one were in Denmark, and it was, I chose it because I know it very well. So that's the reasoning behind that. It could be a lot of everybody else. So it's a center, IT management center in the 1,000th part of Jutland in Denmark, running various different kind of schools, from business college to farming education and a lot of different things, high schools. Early 2007, old-time customer once again. That's our main approach here, and you will hear that many times. They may have some difficulties during their install, everybody have that, but we need to stay on track, we need to support them, we need to be loyal to the staff and to support that they are going to have the growth and the changes going throughout all the years, and that's why we are still behind it. Today running around 450-ish APs, running in 2 controllers, using the onboarding system. So they also do courses for 2 days for some students. So not 1 year, many years, but only for 2 days, maybe 1 day courses. Every student has to be on the onboarding portal. They don't use Eduroam. They use a similar system that we have in Denmark, where we have 1 million accounts in a similar system, but localized only for Denmark. And that's the account database that every student have one account, and they have to use that account to be onboarded into their Wi-Fi system. They don't have their own laptops anymore. It's gone. It's all back to the students having their private device. So I would do around 10 minutes and hopefully a lot of questions coming through, and then we will have a roundup and good time for lunch, I think. It's going to be fine. So I will take a seat and So the management approach, which is what we will have today, is that I assume that pretty much all of the universities represented in here will have stations connected, as we saw, in very, very short time. So if we have a look, just removing that a little bit. It's about 7:45 and 8:20. We are close to 4,000 stations. That's half an hour. So we onboard 4,000 stations in less than half an hour every day. That's what we do. And we see the same kind of capacity in terms of having the throughput up and running. We have to give them the capacity. We see the various number of different kind of stations. Why is that interesting for us or for the staff? They may need to take care of the apple, going the apple way again. Are we going to design everything or change something depending on the stations? What kind of technology do we see? They kind of see 11AC technology already, despite that only 15% is 11AC access points. So that amount of stations is using very few access points actually today. They're just in plans for swapping a lot of 310 plus APs into 11AC. So we expect, of course, to see that one grow a lot in the near future when the access points is swapped. We don't like the red one unless we know that it's offline by reason. Could be that refurbishing campus or something like that, and it's fine, it's okay. We can acknowledge that it's offline, so we don't make any alarms every day. And we also need to do some kind of reporting. When do they need to add access points? When are the day arriving where we need to add access points? How will they make that decision? I mean, we would like to sell the new access points, of course. That's one thing. But when do they need access points? What could trigger that they need new access points? Anyone with a good... When do you need new access points? And why do you need it? More clients?
Yeah, when the capacity is...
Throwing that one. It's on, yeah.
Yeah, when the capacity is getting stretched, then we'll probably need to add more access points.
Yeah. When you mean, sorry, when you mean capacity, is that number of devices?
Both number of devices, number of, or the number of throughput.
Yeah, throughput and devices, yeah. Perfect. Is that the main reason or the only reason for doing, for adding capacity or adding new APs? Yeah, most likely. When I have access points with many devices connected, I might need to add access points. So another question would be, when is there many clients connected to an access point? What's the number? What's a good number? Do we have 10 clients connected to the access point? Is that okay? That's okay. How about 50? Is that okay? Not so good? Or sort of? What we need is that we can't rely on guess. We need to have knowledge. We need to know what's happening. We need to know that. So we do a reporting. That's a management thing. What you see here is that they have an access point, one radio. Remember that every access point has 2 radios. So I'm doing a calculation here, drawing out a report, having 88 stations on one radio. And then I have, can't see it in here, I have another 30, 40 stations, devices on the other radio of that access point. So that's a total of way beyond 100. So you're 50, it's easy. 100 could be tricky per access point, but they are doing that today. Do he need more capacity? In my opinion, yes. He needs to add more access points. He maybe needs to swap some of the old AP to new one, because when you go beyond above 100 clients in one access point, it could be a little bit tough, working, but tough. But now I have the knowledge. I know it's okay to go to my partner and say, okay, I need some more access points. I know to the economics, I know it's okay. I need it because we have a lot of clients connected. Second thing is that it's not just one, it's a lot of access points that have a lot of stations connected on each radio. Talking about throughput, it goes the same. We kind of see that the naming of the access point is the same location. So they have a lot of devices connected. Yes, that's one thing. They consume a lot of bandwidth. Remember, this one is actual throughput on one radio, one physical radio. Adding up, we need access points. So he just needs to deploy a new AP. Hopefully he has some cabling already in place. So give the access point some power, and then he gets divided into more access points that can throw a lot of throughput in the air. But now we know that he needs it. We have to get that knowledge. Unless we're just guessing, yes, we need access points. We can go and monitor and see, yes, that's fine, that's green, we have coverage. But we need it because we have reached our limits, close to our limits. So with roughly 50 per AP, that's 25 per radio. If that were enough, we're above 80 per. So that's 3 times your average capacity. It's running today. And they are happy. That's another very important thing. Another thing I would like to show is that heat maps. How good is our coverage? They have been doing some good stuff here. I have to go all the way to Denmark to get the data, so it may take some time, but it will get there. We are now looking into signal strength. What's my coverage? Do I have the coverage? Because I don't want the students to be at the edge, because as we remembered from earlier, when they are stretching, they get slow. So I want to keep them inside. And I even use this. They have deployed access points very close to the parking lot. Why? Yeah, because everybody comes in the car, Wi-Fi on, smartphone, entering the parking lot. As soon as I can get them connected, when they are in the classroom, they are already connected long time, because when they enter the parking lot, that's a design thing. I don't have to wait till they get into the classroom and get everybody connected, because I connect them very early at the edge. So we need good coverage. As you can see, they need here actually access points in every classroom. Pretty easy. And they will have good coverage. Taking it further to locationing, which is another product, but not today. We can have that kind of similar heat map for locationing. So this is not a big campus, it's a small site, but you need your locationing to find your way around, helping the students to find the next classroom. So that's pretty much easy. We know all about the radio, we know where the wires is and all that stuff. So that's the next level on top of this one. This one is used for making sure that I have enough coverage. And then we could go for last one. I would see if I can find, let's see. Whoops, already there. It's a huge amount of data that I've now done a free text search inside. If I would have searched for an AP name, but anyway, I would have found my access points, or I could have found a student. I'm not going to show you a student today, but that's just an access point. The trend, the graphs, it took me 2 clicks to find that actual access point, going directly down to that access point and see how well or bad, if that happens, it performs. I also see that it's gonna some throughput, various number of throughput over time. And that one is a very big concern for us, for everybody, or should be. How much of my available channel capacity am I using? When do I need more channels? When do I need more capacity? That's when the channel utilization increases and go to the sky. Then I may need to redesign something. This one is pretty nice. I'm only using 20–30% of my available capacity. So they have a lot of capacity in the radio space left. They deploy a single channel. They have some single channels in one area. Remember, they have 6–7 different schools in the environment here. Some of the campus areas is on channel 1. Another one is channel 11, 36, 44, whatever. But they use the single channel technology and the onboarding technique to have it's easy. They can manage. And even though they have 15–20,000 throughout the system a year, they just log in and get connected. Similar to what we saw with the gathering, it has to be easy. Some of them use multiple channels. The business college, typical example. Heavily use video, We just add capacity by adding channels. Not throughout the whole system, but where we need it. And as we saw before with 88 stations on one radio, probably they're going to buy some more APs for that area. Just put it in and more capacity. So I can divide the number of stations onto different access points. Little bit room left for questions. We are right on time. The key factor for us, Alan and I, and nLogic is that education, that's us. Case closed. We do that. We do Wi-Fi, education, high density, flexible environments. So you have different needs, different schools, different designs, and we design accordingly to that. There's a lot of stuff in here. That's a whole day topic, but I think we will save that. We can go on a trip. You have different needs, and happy to visit and ask questions. I will go for the last one here. Is that go live? Yes, we have done, sort of. And questions is, yeah, emailing, phone, whatever. Design is a key thing, and it's not the same design at each level, at each school. We're very much into that. Yeah, if we may, let's have a meeting, and it's going to cost you a cup of coffee or two, and time. But I think it's a good timing for discussing how do we do with your Wi-Fi. That's our core business. Ret og slet. I think that's the right word. Want to finish ending up? Yes. Thank you.